Okay? Good evening. So ipagpatuloy. So alam na natin yung iba't ibang composition and strength of concrete for use in structure. So meron tayong A, B, C, P, and seal. And then wag nating kalimutan yung ibang classification, no, nung lumang classification, yung type AA, type B, type C, at type D. Okay? So ito yon. Okay? So without further ado, actually na-explain ko na naman to nung nakaraang video. So let's proceed. Okay? So this is actually the grading requirements for coarse aggregates depending on the class. Okay? Meron kang class A, class B, class C, class P, at class seal. Okay? So ito yung mga size ng sieve. Okay? So, you might ask class, anong ibig sabihin nitong 63? Or 60, actually, ang 63 na to is yung laki ng butas ng sieve kung saan sinusukat natin yung coarse aggregates. Pag sinabi natin 63, it is equivalent to 2.5. Okay? Sa sinabi ko na, for concrete, usually yung pini-prefer, okay, for example, this is just a trivia, okay, this is a trivia, what is in general construction, okay, so it is a rule of thumb na yung pinakamalaking aggregates natin is 2 inches, okay, so 2 inches, so ibig sabihin dapat sa butas na 2.5 inch ang laki or 63 mm, lahat ng coarse aggregates mo ay magpapass. Ibig sabihin 100% passing. Okay? Lalo na pag class A. Okay? Pag class A dapat sa 50 mm pa lang 100% pasado na. Okay? Sa 50 mm. So ibig sabihin, unlike dito sa B, mag-a-allow tayo ng around 5%, pwedeng mag-a-allow tayo ng 5% na oversized. But somehow yung oversized na sukat ng coarse aggregates natin o yung laki ng graba is hindi lalagpas ng 5%. Okay? So, this is the standard sieve. Okay? Yung sieve is, kung sa Tagalog pa is salaan. Ay, salaan. O sa Bisaya din, no? Salaan. Okay? So, as I said, yung class A natin is ito para sa superstructures. Pag sinabi kasi nating superstructures class, okay, so I will re-explain it. Pag sabi nating superstructures, lahat ng structures sa isang building o isang tulay, for example, o kahit anong uri ng structure, whether it's a building or a non-building, a non-inhabited building, ito yung makikita mo sa taas. So, yan, dapat, class A dapat yan. Okay? Heavy, at pag sinabi natin yung heavy substructures, yun yung nasa ibaba, yun yung nasa lupa, just like footings, yung abutments, okay? Kasi hindi mo siya directly nakikita. Yun yung class A. So yung class B, mas hindi tayo stricto kasi 8 lang, 8 bags per cubic meter, no? 8 bags of 40 kilograms. Ito yun, no? Ibig kong sabihin 40 kilogram per bag. So yung common na bag na nakikita nyo, okay? So yung C, hindi ibig sabihin na C siya is mas mababa yung specs niya. Actually, mas mataas siya ng konti yung cement content niya compared sa A. Ito is para yan sa mga thin reinforced sections. Just like railings, precast. Pwede rin yung gamitin sa reservoir. Okay? Kasi medyo kwan sa gitna yung reservoir. May may malaking may space sa gitna. para i-accommodate yung water, at saka yung wall niya is nasa 100 mm lang. So masasabi nating thin reinforced sections yun. Kaya para sa mga reservoir na made of concrete and also called at mga silos, class C siya. At yung class P naman, ito yung pre-stressed concrete structures. Actually medyo mahirap medyo hindi ko masyadong ma-explain yung pre-stressed structures unless we will introduce in a new subject, pre-stressed concrete. Okay, so maybe in your third year, or I'm not sure, third year or fourth year in college of civil engineering course, BSCE, malalaman nyo in detail ano tong pre-stressed concrete structure. So one of its application is yung girder ng tulay. Okay, yung tulay na madalas yung tinadaanan, pre-stressed concrete yun. Samantalang yung seal is for concrete na deposited in water. Okay, so yan, meron kang iba't ibang specs ng grading ng coarse aggregates. Okay, for class C at class P, posible mas malaki. Okay, so kay class A, yung maximum niya is 2 inches, 50 mm. Okay, dapat nagpass na siya. Kay class B, mag-a-allow tayo ng 2.5 inch, pero yung 2.5 inch mo is dapat 5% or less lang. Okay, okay, class B, nag-a-allow tayo ng 5% na oversized. Kay class C, yung pinakamalaking pinakamalaking specification, pinakamalaking coarse aggregate dapat 3/4 lang. Okay, so you will understand this more kapag nagtrabaho na kayo. Class C. At yung class P naman, 25 or 1 inch yung pinakamalaki. Kay class C, yung deposited sa lupa is 1.5 inch yung laki ng yung pinakamalaking yung pinakamalalaking specified na maximum coarse maximum size of coarse aggregates. Okay, so class A 50 mm, kay class B 63 mm, kay class C 100 mm, kang class P 25 mm, at kay class C 37.5 mm yung maximum size of coarse aggregates niya. So if you want to convert it into inches, you just divide it by 25 mm. Okay, so here are the requirements for fine aggregates. So as I have said, yung fine aggregates is yun yung mas pino pa kaysa sa coarse aggregates mo. Specifically, yung 3/8 or 9.5 mm pababa, matatawag mo na siya na fine aggregates. Okay, so dapat 100% mas maliit kay 9.5 mm. Kapag mas malaki na siya kay 9.5 mm or kay 3/8 na gravel, automatic magiging coarse aggregates. So yan yung pagitan nila. So this is Philippine standards. This is according to the DPWH standards, the latest standard. Okay, so here are the maximum permissible water cement ratio. Okay, when we speak of water cement ratio class, we are speaking in kilograms. Okay, i-convert mo in kilograms yun, hindi volume. Ang water to cement ratio na ginagamit sa DPWH standards or sa Blue Book, sa DPWH Blue Book. Okay, so if hindi pa kayo nakakita ng Blue Book, maybe in the next video ipapakita ko ano yun. Okay, so ito yung specified strength and water cement ratio niya. Okay, so I hope you will forgive me, medyo may kaunting mali dito. Dapat 3,000 tong 20.7 at 2.5 to itong 7.2. So kung meron kang 27.6, okay, yung water cement ratio na kailangan mo is 0.44. When 25.8 or 3750, 0.48. Okay? 24.1 or 3.35, we have 0.51 water to cement ratio. Okay? As I have sent, yung water to cement ratio sa ating sa Philippine standards or sa DPWH standards is in kilograms. Okay? I-convert mo in terms of kilograms si water at yung kay cement. Ito, pasensya na class, dapat ito kay 20.73,000 to. Okay? You should replace this as 3,000 kasi hindi ko ma-replace na kasi na-convert ko na sa PDF. Dapat 3,000 to. So, this is 0.58 eksakto. At itong 17.2, ito yung minimum na strength allowed para sa concrete ay hindi pala 16.5 pala. Okay? Pero ito yung usually sa class B. So dapat ito hindi ito 15252. Then yung maximum water cement ratio niya, actually maximum to class maximum. This is hindi lalagpas ng 0.65. Okay? So this is 3,000 not 25 and this is 2,500. So please forgive me for this one. Okay? And then when we say, so the design mix shall be submitted to the engineer for approval. Okay? So bilang engineer class, ikaw yung nag-a-approve ng design mix. So hindi pwede na yung si foreman mo ang mag-dictate. Ikaw dapat kasi ikaw yung may lisensya. Okay? Ikaw yung may lisensya at ikaw din yung sisisihin sa huli. Okay? Kaya ikaw yung mag-design mix. And speaking of an engineer that is accredited dito sa Pinas, okay? Okay? Na accredited na ng design mix, dapat isa kang materials engineer. Okay? So, yours truly, yung teacher nyo, actually, is an additional license yan sa akin. Okay? So, nakapasa din ako bilang materials engineer 4 years ago. Okay? Nakapasa ako ng civil engineering 7 years ago. Okay? Almost 7 years na akong civil. Then, after that, 3 years nag-experience. Then, nag-take ako ng materials engineering. Pumasa ako. Kaya, at yan, pumasa din ako bilang master plumber. Okay? So, speaking of materials engineer, okay, ikaw yung nag-a-approve accompanied with certified test data and approved laboratory. Okay? So if you are in charge sa quality control, dapat sa batas is accredited materials engineer ka. Okay? Ako is materials engineer 1 ako. Hindi pa ako for 4 years na. Okay? So hindi pa ako pwede, meron pang level 2. Okay? So without further ado, let's proceed na. Okay? So another one is the sampling of concrete. Okay? When we say sampling of concrete, ano bang significance nito? Of course, ang subject natin is construction materials and testing. Okay? Kailangan na walang mangyayaring testing kapag wala kang samples. Okay? So ano ba tong mga samples na to? Okay? This is the significance of proper sampling. Okay? Test results on concrete samples reflect the actual strength of the structure. Okay? Pag sinabi nating kumuha tayo ng sample, okay? In-assume natin na yung nakuha nating sample doon sa field, okay, na kumuha tayo ng konti, yun na yung representative natin para sukatin kung nakapasa ba tayo sa minimum requirements, especially strength requirements. Yun yung pinaka-importante, strength requirements ng ng concrete mo o ng kahit anong materialis mo. Other than strength, meron pang ibang characteristics at properties na tinitest whether concrete o kahit yung aggregates mo at cement na bumubuo ng concrete mo, pati tubig, no? As we have previously discussed. So, ganyan yung sampling. So, if the sampling of samples is incorrect, results may be unsatisfactory, but the concrete may be structurally sound. Okay? So, ibig sabihin, ang other words nito is, hindi naman ibig sabihin na bumagsak yung samples mo, is pagsak na yung structure mo. Okay? At on the other way around, class, pwede rin yung sample mo is erroneous. Ibig sabihin, posible matibay din yung sample mo, pero sa actual hindi. Pero I hope hindi kayo ganyan na engineer, no? Na dinadaya yung testing, okay? So, meron tayong, okay? Ito yung sampling natin, okay? Ang requirement natin is to obtain 3 cylinder sample source, structural concrete. Okay? Beam samples for paving concrete for 75 cubic meter or fraction thereof. Okay? Speaking of that, class, ganito yung sampling natin. Okay? Yung cylinder samples pala is ganito yung forma niya. Okay? Papakita ko lang. So, ito yung forma ng cylinder mo. Okay, cylinder. Okay. So, maghanap tayo ng ibang picture. Actually, tested na to eh. Tested. So, originally, cylinder to, tinetest yung strength niya. Kaya, nilalagay siya sa universal testing machine. At, binibreak doon sa laboratory, tinetest kung pasado ba siya sa compressive strength. Okay? Pag nagsabi tayo ng concrete cylinder, compressive strength yung sine-check natin. So, previously, nalaman natin ano yung minimum requirements ng compressive strength. Sa iba't iba, depende sa type depende sa class ng concrete meron kayo. Okay? Meron pa bang ibang picture dito? Tingnan natin So, I apologize. Okay. Ito. Marami pa. Okay. Yan. Okay. Yan yung concrete sample habang nasa molds pa siya. Kung cylinder molds pa siya. Okay. So, siguro if in the future, pag nagpunta kayo sa site is makikita nyo tong cylinders. Okay. Cylindrical samples. Okay. So, let's proceed na. Okay, so ito. So, ito for every 75 cubic meter, kailangan mo ng 3 sample. Isang set yan. Dapat 3 cylinder samples per 75 cubic meter. Okay? Or, meron pang or dito dapat. Okay, hindi ko nasabi. Okay? So, every 75 cubic meter or 1 day work. Okay? Pag hindi umabot ng 75 cubic meter yung nabuhos mo sa isang araw, for example, magre-represent ka pa rin ng 3 cylinder samples. Okay? So, at least 1 set shall be obtained for each day of concreting work. Okay? Sampling should not be delegated to ordinary laborers or others who have no prior training in materials quality control. As sinabi ko na, ang professional na nag-oversee dito is usually yung mga materials engineer. Okay? So, if ever na makapasa kayo class ng civil engineering, you can, and then you have some experience na, you can also take an additional exam, parang board exam din, pero hindi PRC, galing sa BRS o Bureau of yung BRS, nakalimutan ko na, Bureau of BRS and DPWH. Okay, dalawang sangay ng pamahalaan na magbibigay sa iyo ng additional accreditation license na tinatawag na materials engineer. Okay, in which I would say that I am one of them. Then mas mabuti yung marami kang lisensya class Nang sa ganun is marami ka ring income. Okay? But somehow, I would say na mas mabuti pa rin na madiskarte kayo bilang engineer in the future. Mas nakakayaman yun. Okay? Anyway, let's proceed. So, ano ba yung significance ng proper sampling? Okay. So, particular attention should be given to the protection and curing of molded specimens for strength test due to their small volume compared to the structures. Okay, so they were affected by high temperature and will dry more rapidly than concrete in place. Kaya yung sample natin, yun yung representative ng ano natin, ng binuhos natin na concrete. Kaya dapat alagaan natin. Naalagaan yan. Parang binibaby kumbaga. Okay? Para mag-produce ng mataas na strength. Okay? So, additional samples may be taken for job curing to assist in determining when forms or shoring can be removed. Okay? Pag sinabi mong forms, yun yung forma. At yung shoring, yun yung suporta para hindi bumagsak yung fresh concrete mo on site. Okay? So, medyo verbose na to. Kayo na lang magbasa. Okay? Pwede nyong i-post sandali itong video ito at mabasa nyo ng maayos. Okay? So, yun yung significance ng sampling. Kailangan mo ng samples as a representative of your concrete na nabuhos mo sa site. Whether it is paved or yung sa highway or sa building or any type of structure na ginagawa mo. For every 75 cubic meter or 1 day of work or fraction thereof. Okay. So, ito. So, during early stage of the work, more than the usual number of concrete samples shall be obtained. The extra samples should be tested at earlier dates determine the trend of strength development. So, before that, actually, yung minimum requirements ng DPWH is kailangan meron tayong 3 samples, okay, per 75 cubic meter. Paabutin natin ng 28 days saka natin i-break. Pero posible din if the materials engineer will determine para mas accurate yung pag-test, yung intindihan natin yung strength ng concrete on site is pwede kang maglagay ng additional cylinders para sa 7 days, 14 days at 21 days before 28 days. Yung 28 days dapat 3 yun, pero yung sa 7, 14, 21 pwede tag-isa lang sila. Actually depende yan sa prerogative yan ng materials engineer. So whether the materials engineer is nasa contractor or yung representative ng government agency. Pag yung project nyo is government governed by government agency just like the DPWH or any type of agency. But somehow kahit sa ibang agency yung blue book pa rin yung nagsa-stand. Galing pa rin kay DP yun. Okay? So, yan. So, sampling of freshly mixed concrete, okay? So, you can collect 2 or more portions at regular spaced interval during the discharge of the middle batch, okay? Siyempre, given na yung mga unang batches mo is, parang trial batch pa lang kumbaga, tinatansan nyo pa kung gaano kadaming tubig o gaano kadaming graba at buhangin yung gagamitin mo at saka cement, lalo na pag volumetric yung planta nyo, ang dapat yung kunin is yung nasa gitna, yung middle batch, hindi yung nasa unahan o nasa hulihan. Okay? So do not obtain portions of the composite sample in the very first or last part of the batch discharge. So kaya dapat nasa gitna. Okay? So, for example, nagbuhos kayo, may 10 mixer yung ginamit nyo, or let us say 50. Mas mabuti kung magkuha ka ng sample doon na sa ika 20 plus or ika 30 plus na batch. Oh. Hindi yung nauna o nahuli. So yun is para yun sa stationary mixers. Okay? May I correct myself? Pag sinabi natin stationary mixers, yun yung hindi tumatakbo na mixer. For example, ano yun? Yung ordinaryong mixer lang. Yung bagger mixer, for example, stationary yun. Pero yung revolving drum mixers or agitators, yun yung mixer na tumatakbo. Yung nakikita nyo ba yung mixer? Yung mixer na may track tapos may revolving drum sa likod. Yun. Okay? So, ganun pa rin yung dapat mag-take ka ng samples at 2 or more regularly spaced interval sa middle portion pa rin. At hindi pa rin pwede sa unahan at hulihan. Okay? At saka, one thing is kailangan yung samples mo is nadagdagan na ng tubig, of course. Do not obtain samples until all of the water has been added to the mixer. And then, okay, as sinabi ko na, dapat nasa gitna kakukuha ng sample, hindi yung nasa unahan o hulihan. Okay. Ito na naman. Speaking of sampling requirements, we have the control of consistency. Okay. The consistency of the mixture should be checked frequently by the slump test. Okay, ano ba yung slump test? So, kayo na lang magbasa nito. Okay? Yan. Parang ganito. Okay? Ito yung test, okay, ng slump test. Okay? So, maybe meron akong video dito. Papakita ko sa inyo yung slump test. Okay. Ito pala. So, sana yan.
Today we'd like to demonstrate the ASTM C143 specification, commonly known as slump cone test. The tools we need for the test are a slump cone, a flat non-absorptive surface, a scoop, a tape measure, and a 5
So, yan yung mga gagamitin sa slump tests.
We will begin the test by damping the interior of the slump cone and the base. Place the mold on a rigid, flat, level surface. Hold the mold firmly in place by standing on the 2 foot pieces on either side of the mold. Using a scoop, fill the cone in 3 equal layers by volume, moving the scoop around the perimeter of the cone to ensure an even distribution of concrete. After filling the first third, rod the layer 25 times for each step, uniformly distributing the strokes over the cross-section of the layer. Incline the rod slightly, starting near the perimeter and progressing spirally towards the center. Next, fill the second third of the cone by volume, moving the scoop around the perimeter. Rod the layer 25 times, making sure to penetrate into the first layer approximately 1 inch. Uniformly distribute the strokes over the cross-section of the layer. Fill the remaining third with concrete, filling it slightly over the top of the cone.
So, 3 layers yan, class. Then, 25 stamps each. So,
Rod the
ganun.
layer 25 times, making sure to penetrate into the second layer approximately 1 inch. If at any time the concrete falls below the top of the mold, add additional concrete to keep an excess above the mold. Continue the rodding count from the value reached before the concrete was added. surface of the concrete with the tamping rod in a screeding and rolling motion. While maintaining downward pressure, remove any concrete which is collected around the base of the cone. Raise the cone in a steady vertical direction in a time frame of 5 plus or minus 2 seconds. 1, 1,000, 2, 1,000,
Okay.
3, 1,000.
So, niremove yung mold.
5. What we are now looking for is the shape of the concrete. I am looking to determine if the concrete is sheared off to the side. If that would be the case, this would be an invalid test, and I could rerun the test using a different sample. As we look down at our sample, that is not the case, and we can proceed. We will use the mold and the tamping rod, measuring the bottom of the tamping rod to the original displaced center to the nearest 1/4 inch. In this test, our slump is now 5 3/4 inches, and we can record the results.
Okay? So, that is from Lehigh Hanson Cement Group. So, ganito, ito yung, so, yun yung slump test class. Okay? So, ano bang significant ng slump test? Pag sinabi natin consistency, yun yung, we are talking about the cement paste. Okay? Maraming issue kasi yung cement paste. Posible kasi na nasobrahan ng tubig yung, yung concrete mo. Kaya sinusukat natin yung slump, okay? As usually yung pamamaraan niya is maglagay ka ng 3 layer. Okay, 3 layer ng concrete, fresh concrete sa loob ng slump cone, and then mag 25 stamps ka. Okay? And for each proceeding layer mula sa first, okay, pag for example, first layer, first 1/3 height ng layer is mag-stamp ka ng 25. Another layer, pangalawang layer, 25 naman. But somehow, aabot ng 1 inch doon sa first layer. At pag doon sa third layer, maglalagay ka ulit ng concrete, then mag-stamp ka ulit ng 25. And then meron last, pag medyo kulang, daglagyan mo lang ng konti at saka stamp ka ulit ng 25. And then again, i-move mo yung slump cone, tapos itutuwad mo, then i-measure mo. Actually class, speaking of slump, usually ang slump mo is masasabi nating safe kapag masabi nating hindi ba okay yung concrete mo, hindi masyadong basa or hindi masyadong bags, marami ang tubig kapag ang slump mo is 2 inches or lesser. Okay? So, dapat yun yung standard mo, lalo na sa highway structures o kahit buildings. It should be 2 inches. Will not exceed 2 inches. But, for highway. Okay? So, yan. So, it's an indicator of your water content or water cement ratio. So, ito yung minimum requirement natin. So, depende yan kung ito yung recommended range ng slab. So, para sa slab, sa beams and reinforced wall, you have 3 to 6 inches or 75 to 150 inches. So, yan yung, sa building kasi ito yung sinabi kong 2 inch is para sa general highway. Okay? Sa highway. Then, for building columns, ganun din, 3 to 6 inches. Sa foundation, 50 to 125 mm or 2 to 5 inch. Bakit may minimum and maximum requirement? Pag masyado kasing mababa yung water content natin, baka maliit lang yung slump. So, ibig sabihin, posible kulang din siya ng tubig. Okay? Pag sumobra naman, ibig sabihin, posible maraming tubig. Okay? Mataas yung water to cement ratio niya. Okay? For plain footings, caissons, and substructure, 25 to 100 mm. Pavement, sa sinabi ko na, 2 inch yung minimum to 75. Then, For heavy mass construction, it is 25 to 53. Okay? Ito yung sinabi ko. Yung pinaka-safe na maximum is 50. Rule of thumb na yan. Okay? Para sa heavy mass construction. Yung malakihang bultong pagbuhos ng concrete. Okay? Ito naman tayo sa casting of beam specimens. Okay? Unlike yung cylinder beam specimens, itong beams is ganito yung forma niya. Okay? Yan o. Okay, palakihin natin. So, yan yung forma niya. Ito yung forma ng molds na ito. Ito na rin yung ano niya. So, ito usually sinasample to para sa mga highways. Yung cylinder is para yon sa mga buildings. Yung cylinder. Ito para to sa highway. Para to sa mga kalsada. So, ano ba yung beam specimens? Okay, yan. Ganito yan. So, ito yung mold ng cylinder. Okay? So, nasa na? Ito yung cylinder para to sa building. Ito naman para to sa kalsada. Okay? So, ayan yung gagawin natin. Ayan yung usually nilalagyan natin yan ng oil. Okay? Para hindi dumulas. Yung parang grasa. Okay? No? Nang sa ganun as hindi masira yung molds natin. So, ganun din, 3 layer, pero this time, nasa 20, okay? 3 layer, okay? Hanggang sa umabot sa pinakataas. Then, okay, ganun. So, speaking of, tingnan, i-search ko muna, baka meron tayong, ano dito. Ang tawag dyan, flexural. Flexural. Yan. Eto. So, credits to the owner.
CTTP training videos. AS at the beam loading. This beam broken to determine its flexural strength. Fix bolted 6 by 6 inch BB reached and keep it moist. Original top portion of the restorable strength.
Okay, sorry, hindi ito. Actually, ito yung test ng concrete cylinder. Pero, okay. Beam. Beam samples. Lagyan natin ng beam. Sana na-save ko. Okay? Okay, sensya na. Wala yata dito. Okay? So, ganun yan. Actually, hindi 20, kundi 18 lang pala. Okay? So, 3 layer din. Ganun din yung gagawin mo. 3 layer yan. Then, mag-stamp ka ng 18 times in each layer. And pagkatapos, in each layer, dapat tumagos siya hanggang ilalim. So, and then, the same manner, dapat sa side ka muna magsimula, okay? Sa gilid ka magsimula mag-stamp, at then pagkatapos dun sa gilid, iikot hanggang sa iikot siya pag ganun yung stamp niya, dito hanggang umabot ka sa gitna. Aabot siya ng at least 18 stamps per layer. 3 layer din. Okay, ganyan. So, ito yung casting of cylinder specimen. So, sinabi ko na meron kang 3 layer, then 25 stamps each. Okay. 3 layer yan. And then again, yan. So, ganun din. 25. Katulad pa rin dong sa slump cone. Ang kaibahan lang yun sa slump cone is kailangan mo siyang ilipat tapos ituwad. Okay? Ito, gagawin mo talaga siyang samples. Okay? You will take it in an area na hindi siya masisikatan ng direct sunlight for future purposes, for testing purposes. Okay? So, speaking of curing of concrete samples. So this is to prevent evaporation of water, okay? Cover and specimens with either non-absorptive, non-reactive plate. So a sheet of tough, durable, impervious plastic. Okay, and then remove the specimen from the molds 24 plus minus 8 hours. So meaning 16 to 32 hours after the casting. Yan yung kung pag-cure natin ng concrete sample. So sinabi ko na, pag sinabi natin cure is parang ano natin ba? Parang curing of samples is treat natin yung samples natin is ano natin inaalagaan natin nang sa ganun hindi siya masira na kahit bago pa siya i-test, kaya kinocure natin. So as we proceed, mas maintindihan natin ano itong meaning ng curing. Okay, so specimen shall be moist cured. Ito yung requirements niya. Okay, pag moisture cured siya, 23 plus minus degrees from the time of casting until the date of testing. Okay, so storage during the first 48 hours of concrete shall be vibration free environment. Okay, so sa first 48 hours dapat wala siyang vibration, and then from 25, okay, 23 plus minus 2 degrees naman, so 21 to 25 degrees. So hindi dapat i-store siya sa place na hindi mainit at hindi rin ganun kalamig. Okay, specimen shall not be exposed to dripping or running water. So dapat hindi siya exposed sa running water. Then after 4 to 7 days, pwede mo na siyang i-ship doon sa kung saan siya iti-test sa testing laboratory. So dapat meron kang damp sawdust or hay straw, nang sa ganun is hindi siya mag-break, hindi siya lulukso-lukso kapag tumakbo na yung sasakyan mo na magdadala ng samples doon sa laboratory. And then again, sinabi ko na yung pag-test ng materials is 28 days para sa cylinder at 14 days para sa beam. Okay, 28 days cylinder, 14 days para sa beam. Okay, so testing of concrete samples. So significance of proper testing. So test results on concrete samples reflect the actual strength of the structure. So if the testing of the sample is incorrect, the results may be satisfactory but the concrete may be structurally sound. Okay? So causes of unsatisfactory test results of sample. So ito yung dahilan kung bakit unsatisfactory yung result ng sample natin. Number 1 is yung compaction ng sample. Baka hindi tama, baka hindi umabot ng 25 stamps per layer, o hindi mahina yung pag-mix mo ng using tamping rod. Then incorrect sampling. Okay, mali yung pag-sample mo. Baka doon ka kumuha sa unahan o sa hulihan at hindi sa gitna na batch. Then contamination of sample. For example, is nahaluan ng lupa, nahaluan ng deleterious materials. Then damage to sample. Yung siguro is yung sample mo is na mishandle, kaya nasira. Nagbitak na before pa na test. Then inadequate curing and protection of sample. So hindi mo na cure. Then incorrect test method and procedure. Speaking of curing class, meron tayong dalawang curing. Merong air curing at water curing. Yung samples natin, whether cylinder or beams, is nilulubog natin sa curing tank. Or parang ano siya ba? Parang swimming pool. Maliit na swimming pool, doon nilulubog yung mga samples. Hanggang sa iti-test siya. So, incorrect test method. Okay, inaccurate test result. So this is laboratory This is laboratory caused by improper handling or improper method sa laboratory, and then yung mixed samples. So possibly yung marami kang project tapos nag-mix na, okay, para sa project. So by project yan pag engineer ka malalaman mo na by project yan. So ibang project iba dapat yung samples. So baka naghalo yun, baka sa isang project mo is mas maliit yung strength requirements at is nalipat doon sa building na project na mas malaki yung strength requirements. Okay? Baka yung isang project mo is 3,000 PSI lang yung minimum FC prime at doon sa kabila 4,000 PSI. Kaya mixed. Okay? So I guess mahaba na yung napag-usapan natin sa video na to. So maybe pagpapatuloy natin yung talk in the next video, okay? In the fourth part of our topic about concrete, okay? So stay tuned.